Did you say that boats going over the horizon is proof that the Earth is a curve? Did I hear you correctly?
That's because the boat is actually going over the horizon that's curved. And that means that as it goes farther and farther away, you see less and less of the bottom of it and more of the top of that. You can see that with binoculars.
You're the communications director of NASA, and you're saying that boats going hull first over the horizon is proof that it's a ball? The boat went over the curve? Is that what you said? You said the boat went over the curve. You said the boat went over the curvature of the Earth. That's what you said.
Let's start from the simple to the slightly more complicated. One of the things you can see yourself with a pair of binoculars is if you actually go out to a lake and there are boats on that lake, the farther away a boat is, the more the bottom of the boat will disappear and you'll basically just see the mast of the boat. And as a boat goes farther and farther away, the last thing you will see is the very top of the mast of that boat. And that's because the boat is actually going over the horizon that's curved. And that means that as it goes farther and farther away, you see less and less of the bottom of it and more of the top of that. You can see that with binoculars, by an ocean, by a lake. It's really easy. That wouldn't happen if the Earth were flat. You would simply see the boat getting smaller and smaller and smaller as it went farther away, but you'd be able to see the whole thing with the same proportions.
Now, you cannot see past the horizon. The horizon rises to your eye level, really about your chin, and then you see beyond the horizon. And on a clear day, sometimes you can see 60 miles, 70 miles, 80 miles, and you're seeing above the horizon. Your eyes narrow in on a focal point, and you see a little above what you're seeing. Now, with your binoculars, with your optics, a P900, for example, can bring in these boats, and they did not go over your horizon. You can't see boats go over the horizon. You can't see them go over the horizon. The reason you can't see them go over the horizon is because there is no curve. The horizon is just a vanishing point of perspective, and you're seeing beyond your perspective, and then you're seeing above your perspective, and the level will rise to your eyes. Where the air meets the water, or where the air meets the air, it rises, and you see beyond that. You do not see the curvature of the Earth. You just don't see the curvature of this Earth. You just don't. You look to the left, you look to the right, and it's flat. And you're the communication director of NASA, and you don't know this? You're telling people that we can see the curvature of the Earth? You're telling people that boats go over the curvature of this Earth? No, they don't. Water is at zero elevation. Zero. Always. Water is at zero. Water is level, called sea level. You must have missed that one at NASA school.
Earth's round edges can also be seen in the horizon. Objects nearing it seem to appear and disappear depending on the direction they are moving. We can see this effect when we observe ships in the ocean. If we were to see the horizon from above, we would also be able to see Earth's surface curve at the edges.
So one last thing, which should be obvious,
Okay.
if you pay attention and think about it. If you send a ship straight to the horizon,
Right.
eventually it begins to disappear until it's no longer visible beyond your horizon.
Right.
And you should ask yourself, what kind of surface would produce that result?
The
If,
ocean,
if it's
the ocean has a ramp. That's it. It's like a parking lot. The ocean has a ramp.
And it's an elevator.
Yeah, it's an
at the end.
elevator. And you get to a certain point, and they just like going down.
Seafarers knew this.
Right.
And so, however flat they would have imagined the Earth to be, they couldn't have accepted it to be completely flat, because otherwise you would never not see the ship. Okay.
And not only that, they made sure to photograph him standing there with a really wide-angle lens, which curves horizontal lines. So in the photo, you see this curvature of Earth's surface, and he said, "Wow, he's in space. Look at that." No, he's not. At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat.
Do you know why, Neil? Do you know why? I know. It's because the Earth is flat. It's flat. Now you'll see the camera bounce up and down a little bit, and you'll see it convey and convex a little bit, and then you'll see it go right back to flat. That's the horizon. You can see the sun, you can see the moon at 90,000 feet to 120,000 feet. is there's no proof that they've gone any farther from 90,000 or 120,000 feet. There's no proof that they've gone any farther. That's speculation by NASA saying they did, and you will see a flat horizon line. You will see a straight line. But I do appreciate Neil for saying it's a straight line. That is honest of him. At least he can say a straight line is a straight line. Some of the other guys can't. They can't say a straight line is a straight line. They can't say the horizon is straight. At least Neil can. So bravo for that. I give you props for that. Thank you for at least meeting us at a straight line is a straight line. But it's flat. It's fixed and stationary, and you're not going into that abyss of darkness. There's no way. And it's not moving. Your space isn't moving. Your Earth isn't moving. You can see that it's not moving. It's stationary. From 90,000 feet or 120,000 feet, you should be able to detect a motion, I would think. You would think you'd be able to detect motion from that height, and you can't. You just can't. It's flat. The Earth is flat, man. It's flat Earth.